Okay, I think we will start. Okay, yesterday we people uh, understood the program on polynomial addition and polynomial evaluation using circular singly linked list with the header node. Okay, uh, that program, even it was executed, and all the functions of that program were were explained. Only thing I need to do is the tracing part of the program. I need to do it, so I'll do it later. Okay, maybe Monday I'll try to finish the tracing part. So now we'll just go back and continue with the nonlinear data structure what we were discussing. We had started our discussion with the trees, which is a nonlinear data structure. You understood how the nodes are represented in the using the trees, which is a nonlinear data structure, and then we also understood how do we construct a binary search tree when the list of integers or when the information fields are given. What we do, it's simple, very straightforward it is. It's nothing difficult to construct a binary search tree. So from the given list, we make the first node as the root node. So whatever may be the given list, it may be the list of integers or the list of characters, anything. What you got to do is take the very first item and make it as the root node, and then take the second item, okay, and then just compare that with the root node. When you compare, if it is lesser, so this is what the rule is. If the number is lesser, it should be inserted towards the left subtree. If the number is bigger, it should be inserted towards the right subtree. And this we recursively do until we reach the leaf node, and then we go for appropriately inserting. Now in this example, 5 is the root node because the starting node is made as always the root node, and the next one is 2. Okay, we are taking 2. I'll compare that with 5. Since 2 is less than 5, so we have it inserted towards the left subtree. And then I take 6, compare that with 5. Since 6 is greater than 5, we have it inserted towards the right subtree. Next I take 1. I'll always, you got to start from this root node. I take 1, I compare 1 with 5. Okay, now 1 is lesser than 5, so I go to traverse because 2 and 6 are already added. Since 1 is lesser than 5, I go to travel along the left subtree of 5. Now when I travel, I reach this 2. Now I'll again compare this 1 with 2. 1 is lesser than 2, so it has to be inserted towards the left of the 2, node 2, or it becomes the left subtree for the node 2. Then similarly I take 8, compare that with 5. Since 8 is greater than 5, I travel along the right subtree of 5. I reach 6. Now again I compare 8 with 6. Since 8 is greater than 6, we have it inserted towards the right subtree of 6. So same process we recursively do until all the elements or items of the given input is completed. Okay, this is what we understood. Hope people understood till here.
Yes, sir.
Okay.
Yes, sir.
Yeah. And how many joined now? Okay, it's still 24. Okay, 26. Okay. I think because whatever I do now is important, more important, and one question will be there always. Okay, I hope if this is the strength, I think I have to repeat it on some other day again. Okay, we will see that. And I had asked you to construct the binary search for search tree for this example, and I hope most of you have done it. It's easy. Okay. So next thing that we focus is the tree traversal. Okay, so when it was a singly linked list, and when it was a doubly linked list, and when it was a circular singly linked list, so we used to take a pointer, then we used to traverse it from the beginning till the last node, and then if it is a circular list, from the last node all the way we used to reach back the first node, correct? No, all these things we have done. But how do we traverse the tree, correct? No, in case, say for example, I want to print all the nodes of the trees. Now how do I traverse the tree and go for printing all the nodes? Okay, so there are basically three approaches or three techniques to traverse a tree. Okay, one is Inorder Traversal, another one is Preorder Traversal, and one more last one is Postorder Traversal. Now using these traversal techniques you can go for traversing the trees. Okay, now how do we traverse using Inorder, how do we traverse using Preorder, and how do we traverse using Postorder? So we'll understand that. Now all these tree traversal techniques, all these three tree traversal techniques, they work on the recursion technique. Okay, they're based on the recursive technique. In the earlier classes, you people understood how the tower of an eye problem is solved using the recursive technique, and then similarly the GCD, factorial, Fibonacci. So these are all few problems which can be solved by using the recursive technique. So similarly, so this Inorder Traversal, Preorder Traversal, Postorder, again they are based on what the recursive technique. So hope you people understood till here the tree traversal techniques.
Yes, sir.
Okay.
Yes, sir.
Now each one of these things we are going to discuss now. So you got to carefully understand, because they will give you a tree, and they will, so they might give you the sequence of integer list and ask you to construct the binary search tree. So when they ask you to construct the binary search tree, this is how you got to construct, and later they'll ask you to traverse the tree using Inorder, Preorder, and Postorder. So you may have to traverse each the tree which you constructed using all these three techniques, and you have to write the result of Inorder Traversal, Preorder Traversal, and Postorder Traversal. So maximum this question can go up to sometimes 10 marks and sometimes even 12 marks also maximum. Okay, so carefully understand, that is not at all a difficult thing if you properly understand and follow me. Okay, see, this is what you got to remember. Say I want to do the Inorder Traversal. Okay, sir, I want to do the Inorder Traversal of the given tree. Now how do I traverse? So recursively you got to do this. Okay, so recursively visit the left subtree. Henceforth, instead of saying it as left subtree, I'll be calling it as LST. And then recursively visit the root. Recursively visit the right subtree, okay, that is RST. So henceforth, instead of writing it as right subtree full, I'll be writing it as RST. Okay, so these three you got to remember. Recursively do what? Visit the left subtree, then visit the root node, and then visit the right subtree. So this is the Inorder Traversal. Okay, now here is a simple binary tree we have taken, and we'll try to traverse this simple binary tree by using the Inorder Traversal, by applying this. Okay, I'll take a pen. Okay, so as already mentioned you, okay, what you got to do, you got to traverse the given tree, okay, in this order. First, recursively you got to visit the left subtree, and then the root, and then the right subtree. Okay, now if I'm visiting in this order, so this is the node C is the one that will be printed first. See, order of printing also I have written. So first C gets printed, and next 2 gets printed, and next 3 gets C gets printed, next B gets printed, next A, because third print is this, and next fourth print is D, and next fifth print is the last final print is E. So it is C, B, A, D, E. It is in this order it gets printed. So that is what is the Inorder Traversal of this tree. So so how it is C first and how it is B next, you might be confused. So just look into this. Now what the definition of Inorder Traversal says is, visit the left subtree recursively. So start from the root, keep on recursively visiting the left subtree until you reach the last node. Hope you people are following.
Yes, sir.
Yeah, I start from here. So I'll check whether this node, keep observe my mouse movement also. I'll check whether this node has got a left subtree. Yes, this has a left subtree. I travel here. And again I check whether this has a left subtree. Yes, it has a left subtree. I traverse here. Now again I check whether there is a left subtree for C. There is no left subtree. So recursively, so I've traveled from root, the entire left subtree, okay, and I'm here right now. Okay, next is what? Now for this C, since there are no left subtree and the right subtree, so this itself is the root node. So the root is printed. Okay. Next again, now I have to traverse the right subtree. There is no right subtree for C. Now what I'll do, I'll move back, and this is the root node of C. So B gets printed. Next, I'll look for the right subtree of what? B. So there is no right subtree for B. So if you just observe, there is no right subtree for B. For B there is only left subtree. And again I print B, and then I travel up. Okay, and this is the root node of B, and root gets printed, A gets printed. So C gets printed first, and next B gets printed, and next A gets printed. Okay, now A is printed. Now I check whether there is a right subtree for A. Yes, there is a right subtree for A. What it says now, recursively travel the right subtree. So there is a right subtree for A. I come to D. Okay, and then what I do, I'll check whether there is a left subtree for A. There is no left subtree, sorry, D. There is no left subtree for D. And then what? Root. D gets printed. Okay, and then again, okay, so I travel the right subtree. I'll come to E, and I check whether there is left subtree for this. No. I check whether there is right subtree for this. No. And then E gets printed. So now this is the Inorder Traversal, result of what? Inorder Traversal. So with this, it may be a little confusing for you, but I'll give you a technique, very beautiful techniques using which you can easily write without any confusions. Okay, so just follow this. So I did this without using writing anything recursively. Now I'll go for writing. So just follow my approach. It will be very easy for you. See, what Inorder Traversal says is, first visit the left subtree, and then visit the root, and then visit the right subtree. I'll write here. So this technique you follow, you'll very easily do it. LST, first visit LST, and then the root node, and then RST. Okay, now this is the tree what I'm taking. I'll start from here. Okay, now since I'm always you have to start from what? The top. Remember that. From the root node you got to start. I'm starting from here. Now this node A, okay, what node it is? Root node, and it has a left subtree and it has a right subtree. Okay, and so for A there is a left subtree and there is a right subtree, and this is the root node. So what I'll do, R is root node is nothing but what? A. Following?
Yes, sir.
Next, this LST what I'll do, recursively I have to apply the same thing now. So this LST again can be written as LST root RST. I'll put a box. Following? And then this RST again recursively can be written as LST R RST. Following?
Yes, sir.
Okay. Now, okay. See, A I have written now. Okay. Next, if I come here to A, what is the left subtree? This is the left subtree. And what is the root node for the left subtree of A? B. Following?
Yes, sir.
Yeah. Now here in the place of R, I'll write it as B. This R value is B. Got the point?
Yes, sir.
Okay. Next, I'll go for checking whether there is a left subtree for B. So B has got a left subtree, and after this, so C is the left subtree for B, and after this there are no more nodes. Correct, right?
Yes, sir.
Okay. Now what I'll do, so since B has got the left subtree, again this LST recursively I'll write it as LST R RST, and for this, is there a right subtree for B? This is B. Is there a
No.
right subtree for B? There is no. I don't expand this now. Getting my point?
Yes, sir.
Yeah, this A I'll write as it is. This A is written as it is. Next, okay. 2, is there a, okay, A I've written. Now, there is a left subtree, sorry, right subtree for A. And what is the root node for this? Right subtree for A. It is
D.
D. So here in the place of this R, I'll write it as D. Getting my point?
Yes, sir.
Yeah, and for D, is there a left subtree?
No, sir.
No, I don't go for expanding this now. And for D, is there a right subtree? Yes.
Yes.
I'll go for expanding this RST again recursively as LST R RST. Okay, now come here. Now, so left subtree of B. So there is a left subtree of B, and what is the root node for the left subtree of B? It is C. Correct? R value is how much?
C.
C, because C, this what I've written, this is to the left side of B. Correct? No? What I'm looking now, I'm looking for the root node of the left subtree of B. So left subtree of B is this, and root node is C. I've written here. Is there a left subtree for C?
No, sir.
No, no, I don't go for expanding this. Is there a right subtree for C?
No, sir.
No, I don't go for expanding this also. After C, so what is the node? B, I'll write here. And after B, what is the node? A. Correct? And now, so there was no left subtree for this A. Okay, sorry, D. So next is D itself. This D I'm writing. And then, what is the root node for say there is no left subtree for D, correct? There is no
Yes,
left
sir.
subtree for D, and there is only the right subtree. But what is the root node?
E.
E. I'll write it as E. And for E, again there is no left subtree and right subtree. So this is what the Inorder Traversal. So what I wrote, CBADE, CBADE. Hope you people understood?
Yes, sir.
Yeah, this is very easy.
Yes, sir.
So first you have to write like this. So this is the order. This order you have to remember. LST, root and RST. LST, root and RST. Write the root node and check what is the left side, whether there exists a left subtree for this root node, whether there exists a right subtree for this node. If it exists, go for expanding LST again like this. Go for expanding RST again like this. And this, in the place of R, you just write it as A. That is, this is the position of A. Position of A is fixed now. Next, go for writing the root node of the left subtree of A. So left subtree of A was B. Okay, I've written here. Following?
Yes, sir.
Okay. And then if the left subtree exists for B, then I'll again expand it. If the right subtree exists for B, I'll go for expanding. Since there is no right subtree for B, I've not expanded it. Okay. That means after B, the next node is what? Only A. I've written here. So same thing. I hope you people understood. I'll give you one example to solve. If you solve, you'll understand it. So I want you people to write this example. Okay. Take a piece of paper and write this. So this way, if you do, it is never confusing for you. So that means you have to practice practice it 1 or 2 times. Okay, take simple examples and practice it. So then it will automatically come to you. So copied.
Copying, sir.
Okay. And your DS paper, I have not yet evaluated it, second test. So I think I'll complete. Not yet started also. So tomorrow after 11 I'll start doing it, and I think by evening I'll finish it. So you people can check your marks by logging into the data portal using your login credentials. Tomorrow after 6 p.m. you check it. Okay, my subject, DSA subject. Yeah, shall I move to the next?
Yes, sir.
Okay.
Yes, sir.
Yeah, observe now. So pre-order traversal, same, but the order is different. What the order is saying, first route. So what was the order here? First LST, route, and then RST. Now first route, next left subtree, and then the right subtree. Okay. So observe now here. See, since it says the first route, so what is the node to be printed first? A. See, print first. What? A. Okay, and then the left subtree. Okay, so left subtree for B. So this is the root node for the left subtree of A. Next, what gets printed is B, and next what gets printed is C. Okay, and next is D, and last is E. So same example, but when I traverse this tree using pre-order traversal, so this is the order in which the node gets printed. Okay, now this may be confusing for you. Okay, so now we will try to use the same approach what I showed you for the Inorder Traversal. Okay, I will start writing now. Now it is first root node. The previous one it was left subtree first, and then root, and then right subtree. Root, LST, RST. I'll write like this. Okay. Now I'll start from here. I know the root node for this tree is what? A. I'll put A. Okay. Next, this LST needs to be examined. I'll check whether there is left subtree for the root node A. Does a left subtree exist for the root node A?
Yes, sir.
Yes, it exists. Now LST should be
Yes,
expanded.
sir. Yes, sir.
Now what I'll do, this LST, I'll expand it like this. Again, recursive now it is. I have to expand it. R again, LST, and then RST. Okay, since the left subtree for A exists, so this LST is expanded like this. Now I'll check whether the right subtree exists for A. Yes, right subtree also is there, also exists. Now RST also I'll go for expanding it like this. R, LST, and then RST. Okay, now this is the left subtree expanded, and this is the right subtree expanded. Now I'll go for writing this A as it is. Now this says root node of the left subtree of A. Correct? No? What is the root node for the left subtree of A? It is B. R value is B. B. Next, I go to find the left subtree and right subtree of B. I'll check whether there is a left subtree of B. Yes, B has got a left subtree. Now I'll expand this LST again. R, LST and RST. And now I check whether there is a right subtree for B. Okay, whether there is a right subtree for B. There is no right subtree for B, so I don't go for expanding this. Okay, following?
Yes, sir.
Yeah. Now, so this is from the A's context what I've written. Now I'll take this A. To A, right subtree is existing, and what is the root node for the right subtree of A? It is D. So R value here is D. And I check whether there is a left subtree for D. So there is no left subtree for D, so I don't go for expanding this. Now what I've expanded here is for LST. So if you want, you can put an arrow something like this. And RST I'm not expanding. And since there is no left subtree for D, I don't go for expanding this. I expand, since right subtree is there, I expand RST. So this is for RST what I'm writing. This is R, LST, and then RST. See, if you remember this order, you can easily do it. Now A, B, okay. Now what this R is saying? Root node of the left subtree of B. What is the root node of the left subtree of B?
C.
C it is. This R value is C. Okay. Now I'll check whether do I need to expand this LST and RST. So LST I'll go for expanding only if there is left subtree for C. So there is no left subtree for C, so I don't expand it. And I check whether there is right subtree for C. No, there is no right subtree. I don't expand it. Now I'll write this D as it is. That means since we have reached the end, LST and RST, there is no further expansion. The next character after C is D. Okay. Next I check. Okay. What is this is I've expanded for the right subtree. What is the root node for the right subtree of the node D? So it is E. So this R value is E. I'll write it as E. This R value is E. Since E doesn't have the left subtree and the right subtree, I stop here. So A, B, C, D, E. This is what the preorder traversal, and this is same thing what I wrote earlier. A, B, C, D, E. Okay. So preorder traversal. So copy this also. Copying.
Done, sir.
Okay. Next, so postorder traversal. Okay, see the order now. So postorder traversal, it is LST, RST, and then root. Okay, Inorder Traversal it is LST, root, RST. In Preorder Traversal it is root, LST, and then RST. In Postorder Traversal it is LST, RST, and then root. So this ordering you should not get confused. If you confuse with this ordering itself, then you will go wrong. So if you remember this ordering, correct, no? So then no doubt, correct, you'll solve this problem without any difficulty. Okay. Now observe now. So root should be visited last here. Okay. Observe now. Say I start from here. So what this says, recursively traverse the left subtree. So start from here. I'll check whether there is a left subtree for this A. Yes, I'll travel here, and I'll check again there is a left subtree for this. Yes, I'll travel here, and again I'll check whether there is a left subtree for this? No, there is no left subtree. Now I'll check whether there is a right subtree for this. So because after left subtree I have to recursively traverse what? The right subtree. So there is no left subtree, there is no right subtree, and next what? Root. So this C gets printed. And next I come here. Okay, this is the root node, but this should not be printed now. So first I have to traverse the right subtree, and D gets printed. C, it is D, and then B, and next what? It is E, and finally A. Okay, the root nodes are printed at the end. Okay, see, a root node for C and D is B, so printed after C and D. Okay, and then E, and finally the root node of the entire tree, that is A. Okay, now we will again try to solve this by using the approach which I showed you earlier. Okay, now what I'll do, so LST, RST, and then root node. Okay, I'll start from here. For this entire tree, what is the root node? A. I'll write here. Now I'll go for checking whether there is a left subtree for A. Yes, there is a left subtree. Now I should go for expanding this. So when you're writing this, just write it to the center of the paper. Okay, because when you keep expanding, it gets expanded. Okay, so LST, RST, and then R. Now I check whether there is a right subtree for A. Yes, right subtree for A is also there. So let me write little this side. A I'll write here. Since there is also a right subtree, again recursively, it is LST. So this is the expansion for this, and this is the expansion for this. RST, and then R. Okay. Now since I've expanded this for the left subtree of A, now I'll check what is the root node for the left subtree of A. What is the root node? B. Correct. This is B. Okay. Now I go for checking whether there is a left subtree for B. Yes. So B has got the left subtree, and whether there is a right subtree for B. So you strictly speaking, I have to expand this again. LST, RST, R. Okay, let me do it. So I'll write it little small. So L, R, and the root node R, let me write smaller letter, small r. So this is left subtree, right subtree, and this is root node. And again for this, since that there is right subtree for B also, okay, I'll write it as. So this LST is expanded something like this, and this RST here. L, R, and root node I'll write it as smaller r. Okay. Now I'll come to this A. So I check whether there is a left subtree. R. The root node for the right subtree of A is what? E. This is E, and this A I'll write as it is. And now I check whether there is left subtree for E and right subtree for E. So there is no left subtree and right subtree for E, so I don't go for expanding them. Okay, next here. Now I check what is the root node for the left subtree of B. What is the root node for the left subtree of B?
C.
C it is. C. And no further expansion of L and R, because this is the leaf node. Okay, C. And then I check what is the root node for the right subtree of what? B. That is D. So value of this R is D, and value of this R is C. And then B, and then E, and then A. So this is same thing what I wrote here. So people understood?
Yes, sir.
Okay.
Yes, sir.
Copy this. Now after this I have another example, and you want to solve, you people need to solve it for all the three traversal. Copied?
Yes, sir.
Okay. Yeah, do this now. This is a bit bigger tree. Traverse using Inorder, Preorder and Postorder. This is 40, 30, 10, 25, 8, 11, 20. So this is in the the binary search tree. Say 40 is taken, and say 30 is lesser than 40, and 10 is lesser than 30, and 8 is lesser than 10. So it's constructed the way I told you in the previous classes. And 25 I'll compare with 40. It is lesser. I travel here. I compare 25. Sorry. Oh, okay. Now this is not constructed as per the binary search tree convention. It's okay, no problem. But this is a tree. You got to travel. This is 50. This is 50, 50, 45, 42, 60, 55. Yeah, try to do this. First, traverse it in order. So in order is what? LST, root, RST. Okay, I'll take a blank PPT. Okay, I need this. Yeah, we'll go for solving this now. So in order I'll do first. In order, okay. So you know the in order rule, it is LST, root and then RST. So I'll write L, small r for root, this is small r, and big R for right subtree. Okay. Now what is the root? Tell me.
For left one, sir.
No. Root of this entire tree.
40.
40. So this small r value is now 40. Correct, no?
Yes, sir. Yes, sir.
Next. Now whether 40 has got the left subtree?
Yes, sir.
Yes. Now this L should be expanded again as, I'll write here, L, small r, and then big R. Don't confuse. Big L means left subtree, small r means root node, and this big R means right subtree. And now whether there is a right subtree for 40 also? Yes. So 40 has got the right subtree as well. So L, R, and then R. Observe now. What is the root node? And this L, okay, is expanded like this, and this R is expanded like this. What is the root node for the left subtree of 40?
30.
30. I'll write 30 here. Now I go for checking whether there is a left subtree for 30. Is there a left subtree for 30?
Yes, sir.
I got to expand now. I'll write here L, small r, and then big R. Is there a right subtree for 30? Yes. Again L, R, big R. And this 40 I'll write as it is. Okay. Now, what is the root node? So I'll come to that. Okay. What is the root node for the right subtree of 40?
50.
50. Write 50. And check whether there is the 50 has got the left subtree.
Yes, sir.
Yes, it has got. Now again, so this L is expanded like this here, and this R is expanded like this here. In this L, what we are doing? L, small r, and then big R. Now, is there a right subtree for 50? Yes.
Yes, sir.
Again, L, small r, and then big R. This R is expanded like this. Next, what is the root node for the left subtree of 30?
10.
10 it is. Write 10. Okay. Now, say after 10, okay, so I can go for again expanding it. I'll not do it because after 10, which is the left subtree? 8. So here you should have 8. Okay, I'll write it. And then for the right subtree, this is the leaf node, 11 itself. Okay, R I'll write 11, 8, 10, 11, and this 30 as it is. And now, what is the root node for the right subtree of 30?
25.
See, so 25 I'll write. Now before writing 25, I have to write what? So there is a left subtree for this 25 also. Yes or no?
Yes, sir.
See, strictly speaking, for this R I'll write it as 25. And this L, since there is left subtree for 25, this L again needs to be expanded. Yes or no? And what is the root node for the left subtree of 25? It is 20. Let me put commas. 8, 10, 11, 30, 20, 25. Okay? And then this 40 will be written as it is. Now come to this 50. What is the root node for the left subtree of 50?
45.
45. So this R value is 45. And so is there is a left subtree for 45? Let me write it, no problem, because otherwise it will confuse, I think, for you people. So 45. Okay. So this is R, and this L I'll write as it is, and this is R I'll write as it is, and this 50 I'll write now. So let me put this inside the bracket. This 50 I'll write as it is. Now I'll check whether there is a right subtree for the 50. Yes, right subtree is there. And what is the root node of it? 55. 55. And since this is the last node, I don't go for further expanding it. Next here. So this is 8. So here also you can do the same way how I have done here. 10, 11, 30, 20, 25, 40. Now So is there a left subtree for 45?
Yes, sir.
Yes, that is 42. This is the only node, correct, right? Now before 45 what should come? 42 and then 45. Is there a right subtree for 45? Yes,
Yes, sir.
60 and then 50 and then 55. This is what is Inorder Traversal of this tree. Hope it is clear.
Yes, sir.
Okay, so you have to do that. Similarly,
Yes,
try to do the pre-order traversal. For this example itself, do the pre-order traversal and tell me the order. So just use this instead of writing full LST and RST. For left subtree use L, for right subtree use uppercase R, and for root you use small r. Yeah, start writing. So order of pre-order sequence is this. I'll show you. Root, LST and then RST. Small r, big L and big R. Yeah, do it and tell me the sequence. Have you finished?
Yes, sir.
Yeah. Can you tell the order, the numbers for pre-order? What is the first number?
40,
40,
30,
30,
10.
10, huh?
Yes, sir.
Okay, then
8,
8,
11,
11,
25,
25,
20,
20,
50,
50, okay, 50, then
45,
45, good, then
42,
42,
60 and 65,
60, and then 55.
50.
Yeah. So others please verify. So this is for the pre-order. All of you got this in?
Yes, sir.
Okay. Now similarly, so do post order and tell me the sequence.
Sir,
Yeah, tell me.
post order 8.
Oh, 1 second. Where to write? Yeah, I'll write here. Yeah, tell me. 8,
11,
11,
10,
11, 10. So root comes last, here. First left subtree, right subtree, and then root. Correct? No, this is the order. Okay, correct. Okay, next.
20,
20. Okay.
25,
25. 30.
30,
Yeah, 30.
42,
42. Okay. 60.
60,
Yeah.
45,
45.
55,
55.
50,
50.
40.
40. Good. Yeah, all of you verify with this for post order. And next what we do is we'll be writing the functions to traverse like this. Okay, function for implementing the Inorder Traversal, function for implementing the Preorder Traversal, and function for traversing in the Postorder Traversal. Okay, for everything we write the program. Okay. Okay, now you take this example also, this one. Okay, copy this and try to traverse in all the order. Okay, in order, pre-order, and post-order. So this example I've already copied it the day before yesterday, and this also. So this example you copy. For this you construct the binary search tree. Okay, so using the method what I have told you, and then go for traversing it along all the three traversal techniques. Okay, do this. If those are not copied this example, please do copy this. So you got to copy fast, because I have one more class now from 4:30 to 5:30 for 5th semester. I'll be ending the meeting. So just confirm me after you copy this. So because you know how to construct the binary search tree, you copy only this, the upper one. This number sequence you copy. Okay. And this also you copy. And try to solve it. Okay. So now attendance I will just download. I'll not take it because it's already 4:30. They will be waiting. Okay, only 26 students have attended. Oh, 35. Okay. Okay, it's downloaded. Okay, thank you all, and try to solve those things, and if you have any doubts you can discuss with me in Monday's class. Thank you.
Thank you, sir.